everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is about the tutorial for the chapter 4 and the chapter 4 entitled Network Access. So, to support our communication, the OSI model divides the function of a data network into layers. Each layer works, uh, uh, let's explain the first set. So, the OSI model divides the function of a data network into layers. So, in the previous chapter, I explained about the layers. So, it says here that the OSI model divides the functions of a data network into layers. So, each layer works with the layers because layers above and below to transmit data. So, it says here that the layers uh, above and below to transmit data. So they work. Then the type of connection. So whether connecting to a local printer in the home or website in another country before any network communication can occur, a physical connection to a local network must be established. So this is the home router. So this one is the embedded wireless antenna or the antenna. So this one is this four port are the Ethernet switch or the port. Then this one is for the internet connection. Then the connecting to the wired LAN. Connect your computer to the internet port 1, 2, 3 or 4. So this 4. Uh, you will connect either of this 4 port and then you will connect it to your PC. So the type of connections they have here, and then the network interface cards or the NICs connect a device to the network. Ethernet NICs are used to for a wired connection. So just like here. So the Ethernet NIC used to connect device to a network. So uh, this one used for the device to connect to the Ethernet. The physical layer. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network pages. So, this one is the source node. So they have the application, the presentation session, transport network, data link, and the physical. So they will have the encapsulation and the data in, destination node. Then the physical layer of media. There are three basic forms of a network. So the physical layer produces the presentation and groupings of bits for each type of media as the copper cable, fiber optic cable, and the wireless. So let's start with the copper cables. So the signals are patterns of electrical pulses. So for the copper cable, the signals patterns are the electrical pulses. In fiber optic cable, the pattern of this is the light. And for the wireless, so the pattern of this is for the microwave transmissions or the wavelength. The physical layer standards. So the first one is the physical. The physical layer standards are implemented in hardware and are governed by the many organizations. So the physical has it is all about the physical layer. or the physical object. So it is governed by the several organizations that I discussed in the previous chapter. So there are the ISO, the EAI or the TIA, the ITU-A, the ANSI, and the IEEE. So the TCP/IP standards are implemented in software and governed by the IETF. So the TCP/IP standards are uh, these are implemented in the software. If the physical layer is implemented in the hardware, the TCP/IP standards are implemented in the software, and the TCP/IP uh, standards uh, is governed by the IETF or the Internet Engineering Task Force. So this one is the throughput. So throughput is the measure of the transfer of bits across the media over a given period of time. So it is the throughput is used to measure the transfer of bits across the media. So this one is the measurement is used to measure the transfer of data. Many factors influence throughput, including the amount of traffic, the type of traffic, the latency created by the number of network devices encountered between the source and the destination. So the amount of traffic, and then what traffic is that, and the latency created by the number of network devices. Types of physical media. So I have here the Cisco. So these are the fast Ethernet switch ports, and this one is the SHDSL interface, the management ports, the Gigabit Ethernet interfaces, and the USB Type A connector. So for these two. And then, as an example, standards for copper media are defined for the type of copper cabling used, bandwidth of the communication, type of connectors used, pin out, and color codes of connections to the media and the maximum distance of the media. So I have here the characteristics of copper cabling. So the pure digital signal. So it's like normal. It's going to straight, then down, up, then straight, down. So it's like this one. Then the interface signal is this one, and then the digital signal with interface, and what is the computer reads? It changes the signal. So electromagnetic interface or the EMI or radio frequency interface can distort and corrupt the data signals being carried by the copper media. Uh, so it says here that it can distort or corrupt. So uh, it can destroy. Then the crosstalk is a disturbance caused by the electric or magnetic fields of a signal on one wire to the signal in adjacent. Uh, so the copper media. These are the three main types of copper media used in networking. So the first one is the unshielded twisted pair or the UTP. So the UTP is very familiar for us. So this is the unshielded twisted pair, and this one is the picture of the UTP cable. Then it's called twisted pair because it has a twisted pair here. Then shielded twisted pair, so it's like the UTP, but it has a shield, just like this one. And then the coaxial is this one. Next is unshielded twisted pair cable. So cabling, the QTP cabling is the most common networking media. So as I said before, so it is very common for us. So QTP cabling terminated with RJ45 connectors is used for interconnecting network hosts with intermediate networking devices such as switches and routers. So the QTP or the RJ45 used to connect is used for interconnecting the network host to the intermediate networking devices just like the routers and the switches. So this one is the UTP. So this one is the outer jacket. So it protects the copper wire from the physical damage. So this is the outer layer of the UTP. Then the twisted pair. So protects the signal from interference. So that's why they are in the twisted. Then the color coded plastic insulation. You will notice that it has a different colors, and that color electrically isolates wires from each other and identifies each pair. So we can because of that colors we can identify their uh, uh, their wires because of that color. The shielded twisted pair cable. So the STP provides better noise protection than UTP cabling. So since it has a shield, so it protects more, um, provides better noise protection. So this one is the jacket, then the braided or foil shield. So this one is the shield. So after that, it has also a foil shield, then the twisted pair. The next one is the coaxial cable. Coaxial cable or coax for short gets its name from the fact that there are two conductors that share the same axis as shown. So this one. A copper conductor used to transmit the electronic signals, a layer of flexible. So let's first the copper conductor. So they have this one, the copper conductor. So they have the coaxial connectors have different types. So the B and C, the N type, and the F type. So and then the flexible plastic isolation surrounds the copper conductor. So this one plastic insulation, and then the isolating material is surrounded in the woven copper braid or metallic foil. So this one is the copper conductor. So this is the outer jacket, the braided copper shielding, the plastic insulation, and the copper conductor. So this one. Copper media safety. All three types of copper media are susceptible to fire and electrical hazards. So those copper media are very prone to fire or they and electrical hazards. So they can easily uh, burn, and it is also electrical hazard because it has uh, electricity. So the first is the separation of data and electrical power cabling must comply with safety codes. So they must follow the safety codes for them to easily the uh, for them to easily the for them to call that to prevent the any problems that may occur, then cables must be connected correctly. So it must be correct. Then installation must be inspected for damage. So it should be inspected. So even though it doesn't have uh, uh, a damage, so we need to inspect also to make sure that it doesn't have any damage. Then equipment must be grounded correctly. So this one. The properties of UTP cabling. When used as a networking medium, unshielded twisted pair or the UTP cable consists of four pairs of colors uh, together, and then in case the flexible sheet is smaller size, this one. The first one is the cancellation. So designers now pair wires in a circuit. When two wires in an electrical circuit are placed close together, their magnetic fields are opposite of each other. So that's why they are twisted this one. Varying of number of twists per wire pair. To further enhance the cancellation effect uh, of paired circuits, the wire vary the number of twists. So you can notice here that they have the different number of uh, twists. So you can see here that it has a lot of twists. UTP cabling standards. So they have the category 3 cable UTP, the 5 and 5E cable UTP, and the 6 UTP. For the category 3, used for voice communication, more often used for a phone line. So this one is usually for the phone line. So and then this one, the category 5 is used for data transmission, and for the category is used for the another separator is between each pair. So can you notice here? This one is just a straight, then this one is uh, twisted, and this one is has a separator between each twisted pair. The UTP connector. So this one is the RJ45 plugs. So this one and this one, and the RJ45 UTP socket. So this one and this one. So this you will insert here. Then it says here the bad connector. Wires are explode and twisted and not entirely covered by the sheet. So it must have to be twisted. So this one is the good connector. Wires are wires are untwisted to the extent necessary to attach the connector. So this one is the good connector. Improper cable termination can impact transmission performance. So this one should it can cause damage, or it will or the wire will explode. So this is the types of the UTP cable. So the first is the T568A. So the pair 1 is this one, the pair 2, and the pair 3, pair 4. In the T568, so the pair 1 is this one, the pair 2 is this one, the orange one, the pair 3 is the green, and the pair 4 is the brown. Then the Ethernet straight through, the most common type of networking cable. The Ethernet straight through. Then the Ethernet crossover is connects the two network hosts. So the Ethernet straight through connect a host media to a network. So the network host to a network device, such as the switch or the hub. Then the network crossover is connects to network host connect or the two network hosts, and the rollover is connect a workstation serial port to a router console port using an adapter. So if you will use the rollover, so you will use an adapter. Testing UTP cables. After installation, a UTP cable tester like the one shown below. So this one is should be test for the following parameters. So the wire map, the cable length, the wire map, so the map of the wires. So the cable length, so uh, how length, what is the length of that cable? Signal loss due to infiltration. So any signal loss and the crosstalk. It is recommended to check thoroughly that all UTP installation requirements have been met for them to ensure the connectivity. Properties of fiber optic cabling. So fiber optic cabling is now being used in four types of industries. So the first one is the enterprise network, used for backbone cabling application and interoperating infrastructure devices. So it is mostly used in the infrastructure devices, and the next one is the fiber to the home or the FTTH, used to provide always-on broadband services to homes and small businesses. So the FTTH is used for the our home and small businesses. Then long haul network is used to service provider connect countries and cities. So the long haul network is used to connect the countries and the cities. The next one is the submarine cable network, so used to provide reliable, high-speed, high-capacity solution capable of surviving in harsh undersea environment. A submarine, so they are in the sea, under the sea. So they provide a reliable, high-speed, high-capacity fiber media cable design. So this one is the first. So this one is the jacket. So it protects fiber against abrasion, moisture, and the contaminants. Next one is strengthening material. So this one is the strengthening material, the jacket, the strengthening materials. So surrounds the buffer, prevents the cable from being stretched when it is being pulled. So this one, then the buffer. This one is the buffer, used to help shield the core cladding from damage. And then the cladding made from slightly different chemicals that those are used to create the core. And then the core is actually the light transmission element at the center of the optical fiber. So we have here the core, the cladding, the buffer, the strengthening materials, and the jacket. Types of fiber media. So the laser and the light emitting diode or the LEDs. The fiber optic connector. So this one is the connectors, or the one of the first connector type they use. Then the SC connector is like this one. Refers to a square connectors because it is a square. Then our standard connector. The LC connector, smaller version of fiber optic SC connector. So it's like a smaller version of this one. And then the duplex multi-mode LC connector is similar to LC simplex connector but using a duplex connector. The testing fiber cable. So the misaligned. So they have the tester, the optical time domain, reflectometer. The misaligned. The fiber optic media are not precisely assigned to one when not joined. So they are testing if they have an error in the misalignment. the end gap, the media does not completely touch at the splice or connection. Then the end finish, the media ends are not well polished. Types of wireless media. So the first is the Wi-Fi. So we are very familiar with this, the standard IEEE. So the wireless LAN or the WLAN technology commonly referred to as Wi-Fi. This is a content. So the Wi-Fi is usually known and we are using it in our home. And the next one is the Bluetooth. So the Bluetooth, we know that if we want to share a files for or the pictures or the videos to anyone, so we use the Bluetooth and the WiMAX. This one is commonly known as the worldwide interoperability for microwave access. Uses a point-to-point, uh, point-to-multi-point. So it uses the point-to-multi-point topology to provide wireless broadband access. So they are the wireless media. So this one is the wireless LAN. Implementation is enabled. So this is an example of a wireless LAN. This one. Physical and logical topologies. First one is the physical, refer to a physical connection. So this one, the physical topology refers to the physical connection, the laptop, the PC, the routers, the switches. So that's one. So the logical and also the wireless and also the connectors. The logical topology refers to the way that network transfer frame. So the logical topology is like it is in the uh, network transfer frames from one node to the other. It's like in the software. The logical topology point-to-point links is relatively simple. Half and full duplex. Half duplex connection communication, both devices can transmit and receive data. So let's try this one. So in half duplex, so uh, the hub can send straightly to the server and the server can receive it, and uh, the server can also send to the hub and the sub can receive it properly. Then the next one is the full duplex. So this one. They can send and receive at the same time. So in half duplex, so they are one at a time. If they will send, if they will send, they will wait for their to receive. Then in full duplex, they can both they can do it both at the same time. Frame field. So frame start and stop indicator flags. So the addressing, the type, and then the control, the data, and the error detection. These frame fields are used for error detection and included in the data to form a trailer. So for the summary of this chapter, so all data link layer protocols encapsulated layer 3 PDU within the data field of the frame. So however, the structure of the frame and the fields contained in the header and the trailer vary according to the protocol. So as something simple summary of this chapter, this one is like the it is more common on the in the cables. I told you before the RJ45 or the wireless cable, the copper cable, the fiber optic, the straight, and then the so maybe So that's all for this video. Thank you for watching.